Cirrus clouds are wispy, thin, high-altitude clouds that take on a hair-like appearance. Because they are so thin, cirrus clouds let incoming solar radiation pass right through them nearly completely unabated. However, they still trap and re-radiate the ensuing infrared radiation back to the Earth's surface. As a result, unlike most other clouds, cirrus clouds have a net warming effect on the planet. Cirrus cloud thinning is exactly what it sounds like. It is a form of climate engineering with the goal of further thinning cirrus clouds. This would allow more heat to escape the Earth's surface and be released out of the atmosphere. The thinning would be accomplished almost antithetically by using cloud seeding strategies that release dust particles into the clouds that pull water droplets together, which increases precipitation and then thins the cirrus clouds. While there has not yet been any real-world experiments of cirrus cloud thinning, a team of researchers from the Nevada nonprofit group, the Desert Research Institute, or DRI, have been examining computer simulations of its potential impact. They are particularly looking at vertical cloud distribution data measured via satellite in the polar regions. According to the DRI, there is evidence that cirrus cloud thinning could cool a planet by up to 1.4 degrees Celsius, which would be enough to completely cancel out all the effects of all the greenhouse gas emissions currently being produced. Cirrus cloud thinning would of course impact the environment. The intended effect of thinning the clouds would decrease temperatures locally at the poles where the thinning would be concentrated. But it would also have further impacts around the globe. Decreasing the warming of the poles would slow the melting of the polar ice caps and preserve their high albedo. It would also slow the rate of sea level rise. Additionally, the increased precipitation at the poles may lead to decreased rainfall elsewhere due to the nature of the hydrological cycle. Furthermore, cirrus cloud thinning does not address rising carbon dioxide levels in the atmosphere that leads to ocean acidification, so it cannot be the end-all be-all geoengineering technique that saves us. Cirrus cloud thinning is still in its preliminary stages of research and thus limited infrastructure for its deployment currently exists. And due to the fact that its impacts would be felt most at the poles, particularly in fall and winter, this means that the technology and maintenance would have to be deployed in and endure Earth's harshest conditions pretty much continuously. Additionally, the fact that the poles are located on opposite sides of the planet creates a logistical problem and may require double the resources if the infrastructure cannot be transported. In theory, cirrus cloud thinning has positive climate externalities. It would have a positive impact on the global economy, mostly due to mitigating future climate disasters that would arise if global temperatures would continue to increase in the long run. Furthermore, such a large-scale project would create jobs in the short run as well. Climate change and the warming of the planet will have different effects on different parts of the planet. Therefore, the political support of cirrus cloud thinning will vary from country to country. For example, a country like Russia may benefit from warming temperatures in the Arctic, which would increase its usable land and lead to political opposition against cirrus cloud thinning, while countries such as India may suffer heat waves and drought if climate change were to continue on its current path and cirrus cloud thinning in a future where cirrus cloud thinning is not deployed. Due to its global consequences, an international consensus is required for the application of cirrus cloud thinning. Due to the fact that no real-world tests of cirrus cloud thinning have occurred and that research is limited to a few private institutions, cirrus cloud thinning's future is uncertain. There does exist some concern that the technology may have the opposite of its intended effect and actually lead to an increase in temperature. Thus, any side effects that arise during further research must be closely tracked and monitored. Therefore, more research needs to be done to move cirrus cloud thinning from a theoretical solution to an actual one. Overall, it's still early for the technology for cirrus cloud thinning, but it has the potential to combat climate change. However, it doesn't solve the underlying issue of increasing greenhouse gas emissions and would act more as a band-aid to the problem rather than the solution. As a result, total global cooperation would be required to implement cirrus cloud thinning on a scale that makes a difference.